What I am trying to do very specifically is to develop methodologies for active design of complex adaptive systems such as transportation. And as a result of that, trying to take a step towards breaking the modernization stalemate in the national airspace. The system that we have right now has never actually been ever actively designed. If you look at the history of the system, it's developed in response to accidents mostly and available new technology. However, the system is undergoing big changes in terms of introducing autonomous vehicles. That increases the complexity of the system. So you need to come up with methods that allow you to design rather than just react. And if we can come up with such methods, we can conceivably design a scalable, flexible system that allows many different vehicles to fly into it and not necessarily be bound by complexity of humans having to handle just a few at a time. What has been happening lately that makes me think that my approach is probably going to work is that there's been a lot of development in the area of complexity. So the point is to look at the system and consider what the basic fundamental functional elements of the system are and try to define the control of the system on all scales as a function of those basic elements. And that should allow us to make the problem tractable. Today, I have the fundamental algorithms established, the fundamental approach established, and some basic testing results which show that the problem that I'm asking the system to solve is probably tractable. There are several ways in which this can be applied. I'm hoping that when we propose new methods, when we propose new systems, this methodology allows you to help validate them and to help prove to FAA and ultimately to the public that the system is efficient, safe, scalable, flexible, has good performance.